Assalamu alaikum, brothers and sisters. Welcome to the journey of quest, where we quench your thirst of knowledge. Imagine stepping out onto the red, rocky terrain of Mars, the Earth just a tiny speck in the vast sky above. Could you ever call this alien planet home? Mars, with its stark landscapes and dusty winds, might seem inhospitable at first glance. Yet there's a growing interest in not just visiting, but transforming Mars into a livable space for humans. This ambitious idea is known as terraforming, a process aimed at making another planet's environment similar to Earth's. Why Mars, though? Well, it's the most Earth-like of our neighboring planets, with a day almost as long as ours and ice caps that hint at water's presence. Scientists and dreamers alike see it as the best candidate for a second Earth, a new frontier for human expansion and survival. To turn this sci-fi fantasy into reality, scientists propose terraforming Mars. But what does that really involve? Terraforming sounds like something out of a futuristic novel, doesn't it? Yet, this concept isn't just a flight of fancy. It's a scientific endeavor aimed at transforming alien worlds to support human life. Let's dive into what terraforming really involves. At its core, terraforming refers to the process of altering a planet's environment to make it more Earth-like. This monumental task focuses on adjusting key elements that could allow humans to live on another planet without life support systems. When it comes to Mars, the red planet next door, the primary goals of terraforming are clear: thickening the atmosphere, warming the planet, and introducing water and breathable air. Starting with the atmosphere, Mars's current air is thin and mostly carbon dioxide, which is far from breathable for humans. By thickening the atmosphere, we aim to increase the air pressure to more closely resemble Earth's, making it possible for liquid water to exist on the surface and for humans to potentially breathe without heavy-duty spacesuits. Next, there's the issue of temperature. Mars is frigid, with temperatures that can plummet to -80 degrees Fahrenheit. Warming the planet would involve increasing these temperatures to a more hospitable range where water remains liquid and crops could potentially grow. And speaking of water, introducing sustainable water sources involves melting the planet's ice reserves and possibly creating an artificial hydrological cycle, which would be essential for agriculture and human consumption. Achieving these goals involves a cocktail of cutting-edge science and bold engineering feats. First up in the terraforming process, bulking up Mars's thin atmosphere. Mars presents an atmosphere so scant, it's nearly a vacuum compared to Earth's rich, life-sustaining envelope of air. This thin veil comprises mostly carbon dioxide, with traces of nitrogen and argon, but it lacks the substantial protective layers we enjoy on Earth. To transform Mars into a habitable planet, enhancing this atmosphere is a must. One promising method involves utilizing the planet's own resources. Imagine deploying large solar mirrors around the Martian poles. These mirrors would concentrate sunlight, heating the ice caps predominantly composed of carbon dioxide. As the ice sublimates, it would release carbon dioxide back into the atmosphere, gradually increasing the atmospheric pressure. Additionally, manufacturing plants could be established to process the Martian soil, known as regolith, which is believed to contain bound carbon dioxide and possibly other gases essential for a thicker atmosphere. With a thicker atmosphere, Mars could start to hold onto the heat it needs to support water and life. With a beefier atmosphere, the next step involves turning up the thermostat. Mars, as it stands, is a frigid world, with average temperatures around a chilly -80 degrees Fahrenheit. To transform this cold desert into a habitable environment, we need to significantly raise the planet's temperature. One innovative method proposed is the use of giant space mirrors. These colossal reflectors would orbit Mars, directing additional sunlight onto the Martian surface, effectively acting as an interplanetary magnifying glass. This increase in solar energy would start to warm the surface, gradually melting the polar ice caps. Another approach focuses on darkening the surface of Mars. By spreading dark-colored materials, such as basalt dust, across its landscape, Mars could absorb more solar heat. This is akin to wearing a black t-shirt on a sunny day. It simply gets warmer. These warming methods hint at a Mars where rivers might once again flow. No element is more crucial to life as we know it than water. Mars, often imagined as a barren, desolate world, holds hidden treasures, vast deposits of ice beneath its dusty surface. These deposits are not just remnants of the planet's colder past, but are beacons of hope for future Martian settlers. Turning this ice into liquid water, however, is a formidable challenge. Techniques ranging from the direct heating of ice using mirrors to focus sunlight to the chemical extraction of water from mineral hydrates are under consideration. Each method holds the promise of transforming these frozen resources into usable water reservoirs. But water is just the beginning. To truly make Mars habitable, we must consider the broader ecological implications. Introducing microorganisms capable of photosynthesis would be a pivotal step. These microorganisms could convert the Martian carbon dioxide-rich atmosphere into breathable oxygen, just as plants and algae have done on Earth for billions of years. Moreover, the introduction of specially adapted plant life could kickstart a Martian biosphere. These plants would not only contribute to the oxygenation of the atmosphere, but would begin to create a soil culture capable of supporting more complex life forms. The presence of liquid water and a developing biosphere could eventually lead to a more Earth-like cycle of weather and climate on Mars. In essence, unlocking the potential of water on Mars is about more than survival. It's about creating a self-sustaining ecological system that supports life in all its forms. Water not only supports life, but could also create a more Earth-like cycle of weather and climate on Mars. While the science of terraforming Mars dazzles the imagination, it also poses monumental challenges. As we contemplate transforming the red planet to resemble Earth, the technological hurdles are formidable. First and foremost, we need to develop technologies that can efficiently and sustainably thicken Mars's atmosphere and warm the planet. These technologies are not merely extensions of what we currently possess. They represent leaps in innovation that are currently beyond our grasp. Imagine the complexity of building machines that can release enough greenhouse gases to warm an entire planet, or devising methods to produce and maintain liquid water on a surface subjected to intense radiation and extreme cold. These aren't just engineering problems, they are pioneering ventures into unknown territories of science. The scale alone is staggering. It's one thing to engineer an environment for a small colony, and quite another to engineer an entire planet. Moreover, the ethical considerations are equally challenging. Mars, as far as we know, is a sterile planet, but what if it's not? The potential disruption or destruction of Martian ecosystems that we have yet to discover poses a serious moral dilemma. Terraforming Mars might lead to the extinction of life forms that we have not yet identified, irreversibly altering an alien world. Furthermore, there's the question of our right to alter another planet fundamentally. Do we, as Earthlings, have the ethical clearance to engineer another planet to suit human needs? This is not just about scientific capability, but about interplanetary responsibility. Are we acting as universal stewards, or are we stepping into the cosmos with the arrogance of conquerors? So could we really transform Mars into a second Earth? Let's recap our journey through the ambitious concept of terraforming Mars. We started by thickening the Martian atmosphere, a critical step that involves introducing greenhouse gases to increase pressure and temperature, making it more Earth-like. Then, we explored methods to warm the planet, such as deploying giant mirrors in orbit to reflect sunlight or using dark dust to absorb heat on the surface. Water and life followed, where we discussed the potential of unlocking water from Mars's ice caps and initiating the growth of microbial life, which could further modify the atmosphere and support more complex life forms. Looking ahead, the path is lined with ongoing research and upcoming missions aimed at testing these theories. Scientists and engineers are developing technologies that might one day enable us to seed life on Mars, fundamentally transforming its environment. Terraforming Mars remains a blend of immense possibilities and profound challenges, standing not just as a test of our technology, but of our vision for the future. Thanks for watching us share our videos. Subscribe our YouTube channel and press the bell icon and stay curious for new uploads.